So very good evening, everyone. Vinupriya came, huh? Okay, students. So today our session is very important. Today let us start electric cell. Electric cell. So compulsory this cell concept surely one or two questions will come in both JEE mains and NEET exam also, and very easy. What is the use of the cell? Tell me. It is a source of. It's a source of energy. If you see the any kind of cell, it contain acid or electrolyte. Generally, every cell have acid called hydrochloric acid. What that acid contain? Ions, positive ions and negative ion, cations and anions. Means that is a ocean of positive charged carrier. I mean every cell, one side is acting like a positive terminal and other one is acting like a negative terminal, and in between the two terminals electrolytic acid molecules also there. These ions are very tightly packed, millions and trillions of positive charges are there at very high potential. Okay, if you connect any bulb means what? Any electric resistor, if you create one path, what will happen? Just like how compressed spring will behave, that positive charged carriers immediately will get out of the cell. They will create some current here. Why they will create current? Because of the basic nature of the charge. Basic nature of the charge will flow from where to where? High potential to low potential. Bulb do not have any electrons, but the cell is having lot of electron. When positive charge entered inside the cell, it will encounter millions and trillions of collisions with the acid molecule. Means the acid is also giving some opposition force. That opposition is called what here? Electric resistance. Both of you can sit front, na? Tarani and Soumya, na? Durga, come front. Why is that congested city? I mean, the cell hereafter you can represent like this. Cell means one positive terminal, one negative terminal, and it is also offering some resistance also. So this is a symbol of the cell. Long terminal is called high potential or positive potential. Small terminal is nothing but low potential, and it is also having some internal resistance because of the acid. That small r is called what here? Internal resistance. This is a terminal A and this is a terminal B. Understood. Now the battery not connected to any electrical consumer like bulb or any resistor, not connected. Now if it is not connected to any bulb, these terminals are open, no? Please say yes or no. Is there any current flowing? Is there any current flowing? I am asking. No current will flow. So current flowing equal to 0. I will assume the potential of this is V plus. I will assume the potential of the short terminal is what here? V minus. The potential difference between the two terminals only called EMF of the cell. EMF of the cell. That is denoted with the symbol small e. E is equal to how much? High potential minus low potential. If any positive charge entered, who is driving this positive charge? Attraction force only na? Electromotive force only na? Says or no? The positive charge, whenever it is enter inside the acid, why it is going towards the positive charge? How positive is attracting positive? One driving force required na? Who will take care of the driving force? The cell only will take care of that driving. That's what that potential difference is called electromotive force. Electromotive force, or simply it is called, you can define it as terminal potential difference. Terminal potential difference across the cell. Across the cell. When cell is not connected to, or when cell is open. When cell is open. When cell is in open terminals. Now I will draw once again. This is a cell. This is the internal resistance. Every cell you have to draw like this. This is called cell diagram. I will assume this potential is VA. I will assume this is potential is VB. I will assume this potential is C. This is high potential and this is low potential. Is there any current in the circuit? Cell is not connected to bulb or resistor. It is open. So current equal to how much? 0. I will walk from A to C, C to B. What a potential at A? VA. When I am walking from high to low, potential will decrease minus. What is the potential difference across the cell? I told you E. And resistor, no current is there na. So what a potential difference? 0. Finally, that equal to VB. I mean, what we can write? VA minus VB equal to E. When cell is in open terminals, the terminal difference, terminal potential difference is called EMF of the cell. Is my point clear? Now let us see one special case and important case. If cell is discharging, I am questioning you everyone. Why cell is discharging? Tell me. Why cell is discharging? If you connect it to any electric bulb or iron box or any electrical consumer, fan or fridge or washing machine, that electrical energy it will converting into heat energy. Bulb means light energy. Iron box means heat energy. Fan you connect means mechanical energy or wind energy. Projector you connected means light energy. AC you connected mean mechanical energy. Let us see one example. I am taking one cell of EMF E and its internal resistance how much? Small r. Compulsory you have to draw this like this. This is the cell. Now I connected to one bulb or any electrical consumer. Any electrical consumer is called what, students? External resistor. Capital R means you should understand that is a fridge, washing machine, bulb, fan, something like that. Small r means what? Internal resistance of the cell. Now, how the current will flow? Tell me, all of you. From positive charge to negative charge. When cell is discharging, current always coming out of the cell, out of the positive terminal, and it is circulating like this. This is called cell is discharging. I will assume now this is A junction, this is B junction, this is C junction. Someone tell me what is the total current flowing in the circuit? Who will tell net current formula? Net EMF by net resistance. What net EMF? One and only one source is there, that is the cell only, na? What a net EMF of the cell? E divided by net resistance, how much? Capital R and small r in which combo? Series only. Why series? Same current is flowing. So here many children will slip here. They will tell that small r and capital R in parallel. It is completely wrong, I am telling. How much net resistance? How much? Capital R plus small r. I will keep aside equation number 1. Now I will apply the loop law. What is the loop law? Tell me. I will walk from A to B, then B to C I will walk. What a potential at A? VA. Then I am walking from high to low, means potential will decrease minus. EMF is E. Current is flowing in the internal resistance from high to low. When I am walking from B to C, potential will increase. So plus you have to keep. What is the potential difference across internal resistance? I into small r is equal to VC. VC I will bring this side. So VA minus VC equal to how much? E minus I into R. Very, very important standard formula. Everyone should remember at your fingertips. This is called terminal potential difference. Terminal PD, potential difference across cell. If it is discharging. If it is discharging. And one more very, very important note. Voltage drop across cell equal to voltage drop across external resistance. Shall I write? Please say yes or no. Here potential is VA. Here also how much potential, children? VA. Here potential is VC. Here also how much, tell me? VC. What I mean to say, cell and external resistance in which combination? Parallel, ra? Here how much potential difference is there? Across cell also same potential difference is there, na? Correct or not? So I'll write down that point. Cell and external resistance are in which combination? In parallel combination. That's what their potential differences are same. Understood?
Why negative use?
Why? I'm walking from A to B, no ma. How I'm walking from high potential to low potential. So potential will decrease. So you should put minus here. And the voltage drop is how much? E only, na? So I wrote E. When I'm entering from B to C, how I am walking? Low potential to high potential. Potential rises, no? So you should keep plus. But a potential drop across the internal resistance, I into small r, and is equal to Vc. I need this full slide, copy quickly. Write little bit faster. After a long time discharging, what will happen to the cell? You are using smartphone continuously or laptop continuously. Laptop, smartphone have helium cell, no? What will happen after 3-4 hours? Completely the energy will discharge. What will you do? Again, charge it again. Your smartphone 50 volt means for charging purpose, you will connect it to 10 volt or 250 volt. Your power socket has how much voltage? Tell me. Whatever voltage current entering into our house, 220 volt or 230 volt. America means 250 volt. In India, I think 230 volt. 220, yeah? In building you saw, na? In this building, 230 volt. This is a commercial supply. Commercial supply means a triple phase, heavy voltage required. 230 volt will come. In your house, 220 volt. Single phase. If you put a washing machine and grinder at a time means the fuse will go. Around here, 10 grinders and 20 washing machine, if you nothing will happen. Understood? All, I think 20 air conditioners are there. One air conditioner 8,000 watt. 20 air conditioner at a time you are using also. This high voltage, triple phase voltage will tolerate. But in your house, 5 volt, 5 air conditioner, if you at a time turn on, na, Damal, understood? That's Avada. Okay, it's a single phase. Are you understand? It cannot tolerate that much burden. Are you understanding what I'm saying? So, to charge your phone, you have to connect the power socket. What a power socket voltage? Either 220 volt or 230 volt. Your phone voltage is 50 volt only. 50 or 30 voltage something is there. For charging purpose, you should connect it to high voltage. Where charge will go? From high to low. Are you understanding? You cannot charge the power socket. Are you understanding? Clear or not? Is it clear? So that's what, let us see the charging process of the cell. If cell is charging, same cell I am taking. This is EMF is E and its internal resistance is small r. diagram will be wrong if you do not draw like this. Cell means compulsory. This imaginary rectangle compulsory you should draw. If you do not draw, completely meaning will change. And I want to charge this cell. This is my smartphone. Now what I need to do, tell me students. I have to charge. Where I have to plug in? High potential source. Means power socket only I have to. My laptop is charging na. Have you noticed? Two terminals are there na for my plug that. What is this? Power socket two. And the high potential other one is low potential. So current will circulate from high potential to low potential. So this is a power socket only I am drawing. But this is high voltage na. So somewhat little bit big I will draw. This is, let's say, E prime. It is also having some internal resistance, no? So this is a high voltage source. High voltage source. Now tell me which cell is charging, which cell is discharging. Current will flow from high to low. Now our smartphone is charging and the power socket is discharging. Now directly I can tell what is the potential difference across A and B. Kindly tell me without hesitation what a potential difference across A and B. Very good. VA minus VB equal to how much? E prime minus I into R prime. Why did you say this technique directly? This cell is discharging, no? Power socket is discharging or not? Now directly you can say by using this logic, the terminal potential difference across the discharging cell how much? E prime minus I into R prime. Now same, this is A junction, same this is also B junction. Tell me how current is going inside our smartphone cell or laptop cell? High to low. Big terminal is always high potential. Small terminal is always low potential. And inside the internal resistance, how the current will go? From high to low it will go. Understood or not understand? Now I will calculate potential difference between the A and B I should find. For that I have to walk from where to where? A to C, C to B I have to walk. What a potential at A, tell me? Potential at A, VA. I walk from high to low means I should put minus E. Then inside the internal resistance, how I am walking? High to low means minus I into small r equal to VB. So what a VA minus VB? E plus I into small r. This is a standard formula. I am requesting everyone to remember at your fingertips. If any cell is charging, what is the terminal potential difference across the cell? Very, very important note. If cell is charging, its terminal potential difference how much? Terminal potential difference how much? Tell me. Equal to E plus I into R. Compulsory you should remember at your fingertips. It is a technique very useful to solve the problem very, very quickly and easily without any strain. If you use the techniques now, your brain will not carry any pressure or strain. Okay, one practice problem I will give. You should do that. My question, find current in the circuit. Find current in circuit. First question, many questions are there. Everyone take your own time and answer the question. Tell me. Find current in circuit. 1 ampere. You can do it, very simple problem. Try. 0.5. Okay. Take your own time, no problem. 1 na?
Sir, one.
1 na? Zero?
Think, sir.
Whatever, tell me. 0, huh? Anyway, wrong only this one.
No, sir.
Simple problem only. Don't think critically. You can do.
Sir, 0.5.
0.5. Okay, it is my turn. Which cell is discharging? Down cell is discharging. Up cell is charging. This is A junction means this is also A junction. This is B junction means this is also B junction. So I can write one statement, potential difference across cell which is charging must and should be equal to potential difference across cell which is discharging. Which is charging, what is the potential difference formula? E plus IR means 10 plus I into small r means 10. Which is discharging, what is the terminal potential difference across the cell? E minus IR means 20 minus I into 10. 20 bring this side, this one you send that side. So 10 minus 20 equal to minus 10i minus 10i. Minus 10 equal to how much? Minus 20i. Minus minus cancels out, 10 ones are 10 twos are. So I is equal to how much, tell me? 0.5 ampere.